Now we're looking at linear quadratic systems again, but this time with substitution. But first, let's look at our warm-up. We got to find the solutions to this system. It doesn't say what method. We've done graphing, we've done elimination. So let's look at elimination first. Our two equations are given to us. And remember, when we do elimination, we want to cancel out the y in particular. So I want to multiply this first equation by -1. That gives us negative y equals negative 2x minus 1. And I'm just going to bring the other equation over, y equals x squared minus 2. And then we're just going to add down. The y's cancel out. We get 0, which is what we want. Now this x squared does not have a like term. Negative 2x and x squared are not like terms. Do not add them together or I will throw something at you. So it's just x squared. And there's no x term in the quadratic. So we still just have minus 2x. The only things we can combine are the -1 and the -2 to get a -3. So now we want us to keep solving this. We got to get x. So we do our diamond problem. Our product is -3. Our sum is -2. Should be pretty straightforward. We have a -3 and a 1. So now we can put those right into our factoring form because our coefficient of x squared is 1. So we have x minus 3 and x plus 1. So from that first equation, x minus 3 equals 0, so x equals 3, and x plus 1 equals 0, so x equals -1. So we have our x values. Now we got to find our y values that correlate to those. And we'll use the first equation, because why not? Y equals 2 times 3 plus 1, and y equals 2 times -1 plus 1. So here y equals 6 plus 1, or 7. So we got 3, 7. And over here, we get y equals -2 plus 1, y equals -1. So our ordered pair is -1, -1. So that's elimination. But we can also do it by graphing, because it's listed there. It's pretty easy to do it that way. So the upper right, we have a point where the blue and the red intersect at 3, 7, which is one of our solutions. And our second solution's down on the left in quadrant 3, where we have -1, -1, where they both intersect. And that's the same thing we got when we did elimination. So that's the way it should be. So let's move on a little bit. Today we're going to talk about the substitution method. So we solve a variable, or solve an equation for one variable, and then substitute it into the other equation. It doesn't matter what variable you solve for, it doesn't matter what you substitute in for, it doesn't matter what equation. We're going to isolate one of the equations for one of its variables, so solve for x or solve for y, substitute that junk into x or y depending on the equation, and then solve. So, for instance, solve a linear quadratic system using substitution. We have y equals 3x squared plus 3x minus 5. Then we have 2x minus y equals 3. So we have our two equations. Now the first equation is already solved for y. So y equals 3x squared plus 3x minus 5. So that means anywhere I see a y, I can replace it with 3x squared plus 3x minus 5 because they're equivalent. So we're going to substitute it in there. So we're taking this big quadratic and we're plugging it in for y there. And that's what we have here. 2x minus the whole thing, 3x squared plus 3x minus 5, the orange expression. And of course that equals 3, so everything else is the same. We're writing that equation. So 2x minus, instead of y, we're going to put what it is, equals 3. So again, we're just plugging in what y is. And then what I usually have us do is subtract or distribute the negative, because we're subtracting all three of those terms. So we get a negative 3x squared, a negative 3x, and a positive 5 equals 3. So now we'll combine our 2x and negative 3x to get negative x. Oh, I see what they did. So if we're looking at that, we got 3x squared. We add up those two like terms, we get negative x. And we want to subtract 3 to bring it to the other side. So we have plus 2 equals 0. And like I've said before, we don't want a negative x squared term because it's just messy and we don't need to deal with it. So what we're really going to do is going to take this whole thing and move it to the other side. Can we just move it to the other side? No. So we'd be adding 3x squared. We'll be adding x. We'll be subtracting 2. So that's where they got that equation. From there, we do our diamond problem. Or it's 3 times the negative 2, so negative 6. We want them to add up to 1. So that would be 3 and negative 2. Our coefficient isn't 1, it's 3. So we got to do the long way and do factor by grouping. So we have 3x squared, and instead of x, we're going to replace it with these two. Plus 3x minus 2x minus 2. Then from here, factor by grouping. I can take a 3x out of here, left with x plus 1. I can take a negative 2 out of here, left with x plus 1. So I can factor out an x plus 1. The other part, our leftovers, when we take out the x plus 1s, is 3x minus 2. And of course, all this equals 0. So x plus 1 equals 0, so x equals negative 1. And 3x minus 2 equals 0, so we'd add 2 to both sides and then divide by 3, so x equals 2/3. So that's what they got there. So same thing that we've been doing. Now we still need to find our y values. I don't know why the book didn't do that, but they didn't. So we got to substitute them in. Now which equation is going to be easier to substitute them in for? Either one's probably not too bad. I'm going to use the first equation just because it's already said equal to y. So we're going to use this equation. And we're going to substitute in both x values. So y equals 3 times negative 1 squared plus 3 times negative 1 minus 5. And y equals 3 times 2/3 squared, kind of ugly, plus 3 times 2/3 minus 5. So let's work with the first equation. Negative 1 squared is a positive 1, because a negative times a negative is 1, times 3 is 3. 3 times negative 1 is a minus 3. Whoop. We still got the minus 5. Now we add up our like terms. So the y, these two cancel out, is negative 5. So our first solution is negative 1, negative 5. Our second solution, we have to multiply this out. 2 over 3 squared is 4 over 9 times 3. You can see that we don't need to use a calculator for everything. So 3 over 1 times 4 over 9, because 2 squared is 4, 3 squared is 9. And we multiply that, we get 12 over 9. Kind of ugly, but hopefully things will add up nicely. Then 3 times 2/3, well, the 3's cancel out, so we get 2 minus 5. So it didn't turn out as nice as we had hoped. So we're going to add all that up. And because I don't have a calculator, and most of you don't either, I'm going to write equivalent fractions and do it that way. So I just multiplied the 2 and the 5 both by 9 to get our numerators. So 12 over 9 plus 18 over 9 minus 15, or 45 over 9, excuse me. 12 plus 18 is 30, minus 15 is a negative 15 over 9. That's our y, but we have to simplify. So it's negative 5 over 3. So our other solution is 2/3, comma, negative 5 over 3. Not pretty, but it works. Let's look at some more examples here. Example 2. Again, we want to use substitution. Now, one equation is already solved for y. So wherever y is, we can replace it with 3x squared minus 4x. Well, there's a y there. So we're going to take the 3x squared minus 4x in for the other y. So we get 27 plus y, which is 3x squared minus 4x, equals 14x. Well, let's just rewrite this with in decreasing order. So 3x squared minus 4x plus 27 equals 14x. And of course, to solve this, we need to get equal 0. So subtract 14x. So we have 3x squared negative 18x plus 27 equals 0. So perhaps we can factor this. We don't know. Is there a greatest common factor? Yeah, 3. So we're going to divide all 3 terms by 3. And when we do that, we're left with x squared minus 6x plus 9 equals 0. So 3 times x squared minus 6 plus 9 equals 0. So using the zero product property, either 3 equals 0, which doesn't make any sense, or x squared minus 6x plus 9 equals 0. So now we factor this. We want 2 numbers that multiply to positive 9 and add up to negative 6. Well, that'd be negative 3 and negative 3. And since the coefficient of x squared is 1 now that we took out our GCF, we can skip right to our factored form. So x minus 3 equals 0. So set them each equal to 0. So x equals 3. Obviously, x equals 3 twice. We don't need to write it twice. So there's only one solution. So we have the x value, but we need the y value. And this time, I think, using the first equation, which is already solved for y, is going to be easier. So 3 times x squared, so 3 squared, minus 4 times x. So 3 squared is 9 times 3 is 27. 4 times 3 is 12. 27 minus 12 is 15. So we have our 2 coordinates. 3, 15 is our solution, our only solution for this example. Example 3. Now they're both set equal to y. So it doesn't really matter how you do this, because it's going to be the same thing either way. But again, I'm going to plug in the 4x plus 2 in for this y, because they're equal. But really what we're doing is we're setting the 2 equations equal to each other that are both equal to y. So if y equals 4x plus 2 and y equals x squared plus 2, then obviously 4x plus 2 has to be the same as x squared plus 2. But now, let's get everything on one side so the other side equals 0, and then we'll solve it. So we'll subtract 4x. Now there is no x term on the right side here. Don't add the negative 4x in the x squared. Don't add the negative 4x in the 2. And we also want to subtract 2. Now we do have like terms with the 2, the other 2, but one's positive, one's negative. So on the left they cancel out, which is what we wanted. No other x squared, so it's still just x squared by itself. Then we put in our negative 4x, we put our x term second. And then when we add 2 and negative 2, they cancel out, and that's all we have. So this is going to be nice and easy. The GCF of this one, yeah, it's x. So we take out an x, we're left with x minus 4, and of course, this equals 0. Now, when we multiply 2 things and they equal to 0, either x equals 0, or x minus 4 equals 0, or they both equal 0. So x equals 0, that's done. X minus 4 equals 0, add 4 to both sides, and x equals 4. So we have our x coordinates, but we need our y coordinates. So from here, we need to substitute those values back into one of the equations. Choose the first one because it's solved for y, and it's also doesn't have a square, doesn't have anything else too crazy going on. So y equals 4 times x, which is 0 in this first case. 4 times 0 is 0, plus 2 is just 2. So our first solution is 0, 2. And our second equation, our second solution, is going to be y equals 4 times 4 plus 2. So 4 times 4 is 16, plus 2 is 18. So our other solution is 4, 18. So kind of a bigger number, but we're not looking at the graph, so it doesn't really matter. Example 4. Again, they're both solved for y. I don't think we want to put negative 2x minus 2 in for x in the top equation, because then we'd have to square negative 2x minus 2, do 4 times that, then add everything up together. So it's easier to substitute this into that y. And again, they're both equal to y, so they have to be equal to each other. So x squared plus 4x plus 3 equals negative 2x minus 2. All right, kind of looks okay, but we need to get everything on one side. So we're going to add 2x, cancels out there, and we're going to add 2, cancels out there. So that's what we want, 1 is equal to 0. So x squared is still just x squared. 4x and 2x gives us 6x. And of course, 3 plus 2 is 5. So now we need two numbers to multiply to 5 and add up to 6. Well, that would be 5 and 1. 5 and 1. Finally, we're back. And because our coefficient of x squared is 1, we can skip right to our factored form of this equation. So it's x plus 5 and x plus 1. So we set each one equal to 0. So x plus 5 equals 0, x plus 1 equals 0. Subtract 5, so x equals negative 5. Second equation, we subtract 1, so x equals negative 1. So we have our x values, but now we need our y values. And again, it's probably easier to use this second equation because it's already set equal to y. And we don't have squared, we only have two terms to deal with. So y equals negative 2 times x, or negative 5, minus 2. And y equals negative 2 times negative 1, minus 2. So let's just work through this. Negative 2 times negative 5 is positive 10. 10 minus 2, of course, is 8. So we have one solution of negative 5, 8. We keep going with the bottom equation there. Negative 2 times negative 1 is 2. Minus 2 is 0. So our other solution is negative 1, comma 0. There's our two solutions for example 4. Our last example here, we're going to plug this in for that y. Because negative 3x squared plus x plus 4 is y. It's equal to y. So we're going to replace y with what it's equal to. And what we end up getting is negative 3x squared plus x plus 4, that's our y, minus 4x, which was already in the equation, equals negative 2. Now, we want to get this set equal to 0 so we can solve it. We also want a positive x squared term. So let's add 3x squared to both sides. Cancels out over here. We're going to subtract x from both sides. Cancels out over here. And we're going to subtract 4. And we're going to add 4x. So we're just pushing everything over to the right side. So on the left, everything cancels out. On the right, we got the only squared term we have is 3x squared. We have a negative x and a positive 4x, so positive 3x when we combine those, and a negative 2 and a negative 4 gives us negative 6. So we need to solve this. First thing we should do is a GCF. We do have one, it's 3. So we factor that out, divide all three of those terms by 3. So we're left with this. Now, something times something is 0. 3 times x squared plus x minus 2 is 0. So either 3 is equal to 0, which doesn't make any sense, or x squared plus x minus 2 equals 0. So from here, we need a factor. Negative 2 is our product. Our sum is 1, because our coefficient there is 1. So 2 and negative 1 multiply to negative 2, but add up to 1. And because we took out our GCF of 3, our x squared coefficient is 1, and we can skip right to our factored form of our equation. So x plus 2 and x minus 1. Then we set them equal to 0 and solve for x. So x is negative 2 or x is 1. So last step is to substitute those in for x. And you can use either equation. I'm not sure either one of them is super nice, but we'll do the second one because there's less terms. Y minus 4 times negative 2 equals negative 2, and y minus 4 times 1 equals negative 2. So that's y, negative 4 times negative 2 is a positive 8, equals negative 2. We're going to subtract 8 from both sides, so y equals negative 10. So we have negative 2, negative 10, one solution. The other one, y minus 4 equals negative 2, add 4 to both sides, and y equals 2. So we have our second solution. Our x was 1 and our y was 2. So there are two solutions. That's what we're doing with substitution method.